So we were discussing about the minor grid lines, so that you can see from this figure much more clearly. You can see the major grid lines here. These are the major grid lines, and whatever is you are seeing inside this is the minor grid lines, okay, with same color. So that is the basic idea here. So the minor grid lines are dotted because we have used a colon instead of, we have used this minus sign for line, and we have used this colon for minor grid line. So this colon will give you a dotted line. Okay, so next instruction is the X label. This we don't have to discuss much because just it just give you the label for x-axis, plt.x label, that is time in second, and plt.y label, which is velocity in meter per second, and we have given title of the plot, which is plt.title, projectile of a rocket. And now plt.scatter, this is for the scattered plot of the data which we have given already. So that is the original data, that's why we have given label original data. And here we can see we have given t and v for plotting the scattered data. So it will automatically take from that array what is the value of t and v, and it will plot. And the size of this scattered plot we have considered, that is the default dots will come, and that dot size is 50, and this is for color. As you can see, this is 255 only here, the other values are 0, so it will be a red dot. Okay, now we will consider next line, next instruction. So next instruction is plt.legend. It is nothing but you had to show the legends in your plot, and the location is given, location loc loc equal to upper left, so it will come in the upper left of your figure plotting. So this is the legend that is in upper left of your plot, and you can see from here these dots are coming, that is random plot dots. These are in red color and size of 50. Okay, and you can see the labels also, axis labels, and we can also see the title of the figure. So all these we have already given. Okay, so I am just giving you some hand to know what are the instruction, how it is working. Now if you consider the next line, next instruction, we have plt.plot 16. This is actually we don't need, because we are just constructing a line which is passing through t equal to 16. Okay, you can see from here this line I am talking about. Okay, so let's zoom it a little more. So you can see this line, there is a line at t equal to 16, this line which is going up to this. Okay, that line is the description of this particular plt.plot. So we have 16, we have set 16 comma 16, that is the in time line or time axis we have fixed the value 16, and then we have the y value or the v velocity, which is varying from 0 to maximum velocity, and p dot maximum of the velocity value that you have given, that is the y line, so in a change in y. Then we have the corresponding color. We can see here red is 0, blue and green only available, and green is more, so it will be more greenish color. Okay, so that's just a line which is just at 16. Now we have the if you plot this, then we can have a figure or plot like this, as you already seen here. And this is the rough plot of the scattered plot of the given data. Okay. Now if you go to that YouTube video, then you can see he is describing some nearest by using the nearest point method we can interpolate. So he is describing something like that. So that is not that much important for you, as we are not considering that in our study, but it is also important. In that what we have to look is, if you want to evaluate y at t equal to 16, then you have to check which y value which is in already given y value is close to that or nearest to 16 point, then that will be your result. So it is another method of interpolation, but we are first looking here for a linear interpolation. So for linear interpolation we have to give time. So what we are giving here is np dot array. So we are constructing one more array which is having first element 1 and the second element which is t of 2, that is t we already given here as an array. So t of 2 will be nothing but your 15. Okay, t of 0 is 0, t of 1 is 10 and t of 2 is 15. And so in the next row we have first element 1 and second element is t of 3. So t of 3 is nothing but your this 20. Okay, so here basically we are constructing this matrix. Okay, this will give you a matrix which is 1 is first element and second element is 15. Okay, second element is 15, then you have again second row we have 1 and next element is, I think it is 20, right? It's 20. So you are constructing a matrix like this. Okay, now we have this T linear matrix, then we have V linear matrix, which is nothing but for linear interpolation we are constructing the tree matrix and V matrix, that is T lin and V lin. And from we have already defined what is V, that is as an array. From that we are taking the second and third element, that is our V matrix. So V will be having like, that is V lin, not V, it is V lin. So V lin is nothing but we have two second and third element. We have second and third element means that which one? So V of 0 is 0, V of 1 is 227 and V of 2 is this one 362.78 and V of 3 is 517.35. 362 point, so we have 362.78 and 517.35. 517.35. So we have basically this, we have created these matrices. Now we have to use this np.linear algebra, np.linear algebra to use this to solve these equations for to get the coefficient. So we will give you us these matrices in this solve. You can see here, you can see here np.linear algebra solve t lin comma v lin, then it whatever it is value which is stored as a lin. Okay, here a lin. Now you put t16 lin as 1 comma 16. So you will be having a matrix which is element is 1 comma 16. So then you have to take dot product of a lin and t16, then you will get the corresponding velocity. Okay, we will discuss from here in the next lecture.